Well, we have another question here, question 9. The question says that a closed rectangular box has to be constructed as follows. Dimensions: length L, width W, and height H. The length L of the box has to be 3 times its width. The volume has to be 5 meters cubed. The material for the top and the bottom parts costs 15 rand per square meter, and the material for the site costs 6 rand per square meter. Now, question 9.1 says, show that the cost to construct the box can be calculated by cost equal to 90 W squared plus 48 WH. So I'm gonna write the question over here. So we need to prove that 9.1, the cost will be equal to 90 W squared plus 48 WH. This is the cost. Now, I prefer to represent the diagram, to represent the box here in the equation, okay, before I start solving it. So I'm gonna do like, let's say, the box is here. Okay. Okay. I'll move it a little bit this way. Okay. Yeah. And then it goes like, okay. Yeah, let's say this is the box, okay? They said that the length is L, the width is W, and the height is H. And the volume is given to be 5 meter cubed. Now, so because we need to prove the cost, okay, to prove that the cost is this amount, and we need to consider the cost of per square meter. Here it is, excuse me, here it is said that the material for the top and bottom costs 15 rand. So the top is this one, and the bottom will be underneath there. So because, let me show the inner parts also of the box. Something like, so the top is over here, and then the bottom is just space there. So I will change the color. I'm gonna draw here with this color to show the top. The top is this one. Okay. So I'm gonna work out first the total surface area. The area of the top. Remember, the area of the top of the box is the same as the area of the bottom. So the top and the bottom are just the same thing. So this one's in red. Okay, so this will be what you see, that it's the length times the width. Okay, so this one will be like length times width. But remember, it's the same area repeated twice, because this is at the bottom, it is also at the top. So I'm gonna say times 2 here. Okay, now we have that, and also what else do we have? Let's work out the area of this side, the front side. So we have like one here. Okay. Okay, it is there, as you see, and it is also there at the back. Okay. So it's the same area. So because the length here is L and the height is W, so we're going to write here plus, okay, length, actually H, okay, because it's the length times H, but because it's twice, we have it here, and then the other one at the back, so I can just say 2 here. Now remember that here we times this part by this costs like 15 rand, okay? It's times 15, this area, and this one is 6 rand, as it is said over here. 6 rand. Okay, so maybe I show. So this is 6 rand, 6 rand. This one, and then over here, we times by 15. Okay, 15 rand times by 15 rand. Okay, and then the other areas, the other sites are the sites here. This one and that one. Okay, these two sides also, it will be like W, okay, and then times the height H. So because it is 2, I want to say plus 2 WH. Now, again, over here, we will times this by 6 because it is also the area of this by 6 rand. Now, to calculate now the cost, okay, because this is the area of the total area, the total surface area of the box. Now to calculate this cost, we will times before even at times, I would like to give the value. Remember, it is say that over here it is say that the length is just 3 times the width. Okay, I can improve my answer here. I can just say 2 L is 3W, so times here by 3W times 3W, okay, times W plus 2L times H plus, oh, sorry, here instead of say L, I just want to times by L is just 3W, okay, and then times H, okay, plus 2WH. Now, we can simplify this further. This will be like 6W squared, okay, plus 6WH, 6WH, and then plus 2WH. Now, to work out the costs, then the costs will be 15 here times 6W squared. 15 times 6 is equal to 90. You can check in the calculator. If you're unsure, if you're unsure, you can just do 6 times 15. That's equal to 90. You see, so it's going to be 90W squared. So at times this 15 rand, the cost of the top, okay, 90 plus. Now here we're going to do 6 rand times 6WH. That makes 36 WH, and then over here we could just combine, okay, because this is like this is like 6WH plus 2WH, okay, the two together makes 8WH, okay. I prefer to do that one. Wait, before even I do the costs, I can simplify. So this is like just 6W squared plus 8WH. Now I can substitute. Remember, this is the area of the top cost 15 rand. I'll times here by 15 to find the cost. Let's just move my board a little bit up like that. So the cost will be equal to 90 W squared, because I times 15 by 6, and then here I times 8 by 6, okay? This will be equal to 8 times 6 is 48 WH, and then this is proven. This is proven. Okay, and then the following question is question 9.2. The question says that determine the width of the box such that the cost to build the box is a minimum. Okay, so now when we talk about the minimum cost, it's when we're going to that optimization, right? I mean, we're going to to work out the derivative and set the derivative of the function equal to 0. Okay. Now let's do it. And I'll do it over here. Question 9.2. Looking for the width that will make the volume of the box the minimum. Okay. I mean, the cost of building it is the minimum. Okay. Now let's do it. Okay. We did prove that we already proved that the cost is equal to is expressed like this. Okay. And then the volume of the box here, the box that I draw, the volume of the box is obviously length times width times h. Okay. So now we can substitute the value of the length. The length is like 3w. Okay. 3w, and then the width is w, and then the length, the h is h, and now the volume is given by 5. Okay. So 5 meter cubed equal to 3w squared h. Now we can express h here. We can find h in terms of w because we already expressed L in terms of w. We can now also express h in terms of w, and this will be like if I divide both sides by 3w squared. Okay, 3w squared. This will be like h will be equal to 5. H will be equal to 5 over 3w squared. Now I have h in terms of w. Now my costs then will become, it was given by 90 w squared plus 48 wh. I will not write this anymore. I will substitute by the value. Okay. It's going to be like the cost with respect to functions of w. Okay. Which is like 90 w squared plus 48 w times 5 over 3w squared. This is h. Okay. Now that this part here is just h. Okay. So this will become then 90 w squared plus 48 times 5 is equal to 48 times 5. Okay, let's first do 48 divided by 3. You know, we can divide here by 3. 48 by 3 is 16. So 16 times 5 is 80. So that makes 80, and then also w, and one of the w here, it's gone. So it's going to be like 80 over w. So this is the cost in terms of w. Now, to find the minimum value is when we're going to differentiate the function. Okay, we're gonna differentiate this function, and this will be I'm gonna do it over here. To find the minimum cost, then I'm gonna set to find the minimum cost. Like here, it's when we do c, when we put c prime. Okay, cw prime is equal to 0. Okay, so remember that to find the derivative of a polynomial, we're going to differentiate each term of the polynomial. So it's like if you have like a x to the power of n, derivative, this is equal to n times a times x to the power of n minus 1. Okay, so over here we did find that the cost with respect to the width is equal to 90 w squared plus 80 over w. Okay, this can be rewritten. I want to write it in the simple way for us to differentiate it. I want to say costs with respect to w will be like 90 w squared plus 80 w to the power of -1. Okay, remember this law of exponent that says 1 over a to the m equal to a to the -m. Okay, that law apply. Now let's differentiate it. This is going to be like c prime. It's going to be like c prime of w will be equal to 2 times 90 times w to the power of 2 minus 1. Okay, and then plus, okay, -1 times 80 times w to the power of -1 minus 1. And now C prime w will be equal to 180 w minus 80 w to the power of -2. Now we're going to set this equal to 0. So now because that was the condition for us to get the minimum value. It's when we set this equal to 0 there. And now this will be 180 w minus 80 w to the -2 equal to 0. If I move, for instance, okay, or maybe, yeah, let's move the 80 w over, so that makes 80 w minus will be equal to 80. Okay, I won't do that yet. Let me just do 80 over w squared equal to 0. Okay. Then I can times the whole equation by w squared in order to cancel this. So I want to times here. I want to times here by w squared. I times by w squared, the whole equation. So that's when we do this times that, this will make 180 w cubed, okay? And then when I will do this times that, it will cancel, okay? This and this will cancel, and then I'm left with -80 equal to 0. Okay, so to work out this, I can move -80 over. That makes 180 w cubed equal to 80, and then I can divide both sides by 180, both sides of the equation by 180, and then this will be, I can just move my board this way. Okay, this will be like w cubed will be equal to 180 divided by 180, so we can just divide like this. It's gonna be by 2 by 2, it's gonna be like 4 over 9. So this will make like 4 over 9. 4 over 9. Then w will be, to find w, I'm going to cube root this part. Cube root 4 over 9 here. Then we can use a calculator to find the cube root of 4 over 9. To find the cube root, then in the calculator, you press shift like this, and then you press this square root button, okay? It gives you the cube root. Then we can write there 4 over 9, and then we press equal, and this delta W will be equal to 0.76 meters. So if W is 0.76 meter, we will get the minimum cost. This will give us the minimum cost. Thank you.